So this is a virtual wall, essentially a wall that is using a stereo correspondence to extract depth, and we're able to deduce the depth of the hand with respect to the wall and allow a user to interact with this wall. So the first step of the program is to acquire the corners of the wall. So as you can see here, a contour has been deduced from this binary image, and we've identified the polygon that represents the wall. So now we've locked in this, you can see nothing can change the borders, the contour. So we've locked in the wall, and now we get into the algorithm that allows us to detect a hand and detect a fingertip. So the first step of this is to use a background subtractor. So the most basic understanding of a background subtractor is that it uses motion to segment the foreground from the background. And in this particular KNN background subtractor from OpenCV, we've been able to not only extract the background and the foreground, but we've been able to distinguish shadows from real objects. So as you can see, I'll be interacting with the wall and there is a shadow, but this function has been able to differentiate between the shadow and the real object. And because shadows are gray and the objects are white, we've been able to do segmentation, grayscale segmentation. So now we're able to have the no shadow image side by side with the shadow image, and as you can see, the shadows have largely gone away. So after getting the foreground from motion, you may be wondering about how to extract the rigid shape of a hand or a body. And you can see it's particularly when you're still, but in general this form is rather sparse. So we use something called morphology. There's a number of different things we've done. We've done a little bit of erosion to get rid of the bright pixels, the little tiny pixels that are from illumination changes. So that's erosion. And trying to find the morphology. Okay, so our ultimate goal is really to contour the hand, or yes, contour the hand so that we're able to detect its location in the grid. As you can see, we've applied the morphology, we've gotten rid of some of the noise, we've also done some dilation, some gradient morphology, and we've gotten kind of a more rigid representation of the hand. To further bound our problem, we've actually taken a mask of the wall and we've applied this mask to the morphology, and we've done some sorting and analysis on contours, including enclosed area, center of mass, and its location in the grid. And in general, we're able to extract the position of both the center of this contour and the rightmost tip, which is the fingertip. So if we move slowly and kind of take our body out of the frame, we are pretty well able to kind of track this finger around the wall, and one of the main challenges here is the fact that we didn't have color. So the stereo camera, which is the Mint Eye, does not have color. So the problem is a very common way to do skin detection or hand detection is using color-based segmentation using the HSV color space, which we have attempted with a regular webcam, but it's not available in stereo. So we had to do a lot of work with the motion and shaping and contouring and sorting and masking and all that to kind of get the hand. And the this image is a heat map that is proportional to the depth. So we have a absolute depth available to us, and really you can tell that wherever the hand, when the depth of the hand is within a certain range of the wall, we're in the wall. So as you can see, the red or the hot means closer, and the blue is farther away. So so when our hand gets close enough to the wall, it kind of blends in with the color of the wall, and numerically, that's where we threshold it and say, is our hand close enough to the wall or not? And if it is, we identify the coordinate, and then we can actually make it play noises or give some auditory feedback to allow the user to interact with the wall. So that is the main premise of this, and thank you for listening.